Welcome to our third video in the Pythagoras video series. So today we'll be talking about Pythagorean triads. Now, the purpose of talking about Pythagorean triads is to help you with day-to-day calculations, especially when you don't have a calculator handy with you. So in the previous lesson, some questions had really nice whole numbers, but let's just have a quick look at the hypotenuse of both of these two triangles. So if we just try and calculate the hypotenuse of this first triangle, we would say, first, let's just let the hypotenuse be x. And we can say that x squared is equal to a squared plus b squared, which in this case would be 3 squared plus 4 squared. And so we get x squared is equal to 25 because 3 squared is 9 and 4 squared is 16. And so to find out x, we just square root 25. And we're left with 5. So we can say that our hypotenuse in this particular example is going to be 5. But now let's have a look at the example over here. Well, let's just call this y now. So we can say the Pythagorean statement would be y squared is equal to a squared plus b squared, which in this case is going to be 4 squared plus 7 squared. And so we're left with y squared is equal to 16 plus 49. And in that case, 16 plus 49 is equal to 65. And so we can say that y is equal to the square root of 65. Now, if you put root 65 into your calculator, you're going to get some sort of decimal answer. It's not going to be a clean number. So let's just recap what we've done so far. So we've figured out that the hypotenuse for this triangle is 5. And the hypotenuse for this triangle is root 65. Now, what do you notice? Well, you see that the ratios of these sides are in whole numbers. You can see 3 to 4 to 5. These whole numbers mean that 3 squared plus 4 squared is equal to 5 squared. Whereas in this triangle over here, 4 squared plus 7 squared would equal root 65 squared. So what's the significance of all this? So the whole idea behind Pythagorean triads actually lies in the name itself, tri. Tri means 3. So really a triad is a set of 3 numbers which satisfies Pythagoras' theorem. So we've already thought of 3, 4, and 5. So that is one triad because we can see 3 squared plus 4 squared is equal to 5 squared. Now, in order for us to have a Pythagorean triad, all of the numbers in the set have to be whole numbers. So another example might be something like 5, 12, and 13. We can show that this is the case quite easily because we can say that 5 squared plus 12 squared is equal to 13 squared. Let's just double check that's right. We know that 5 squared is going to be 25. We know that 12 squared is going to be 144, and 25 plus 144 is 169, and that is indeed the same as 13 squared. So now, pause the video and think of 3 numbers that also satisfy Pythagoras' theorem, making sure that they're all whole numbers. Okay, so let's see what you thought of. Here are some common Pythagorean triads which I think are worthwhile memorizing. Now you can see 3, 4, 5 is quite a basic one. Now 6, 8, 10 is not actually a Pythagorean triad. In fact, it's actually just an extension of 3, 4, 5. You can see that 6, 8, and 10 does satisfy the rule because 6 squared plus 8 squared is equal to 10 squared. But you can see that all I've done is I've multiplied 3 by 2, I've multiplied 4 by 2, and I've multiplied 5 by 2. 7, 24, 25 is another basic triad. We have 8, 15, and 17, 20, 21, and 29, and 5, 12, and 13, as I mentioned before. So what's the purpose of this? So on this slide, you can see there's 4 triangles and they represent 4 different triads. You can see the 5, 12, 13 triads being represented in this triangle, 3, 4, 5 on this one, 7, 24, 25 on this one, and 9, 40, 41 on this one. Now, I want you to understand that these triads don't have to exist just as 5, 12, 13. For example, If I had multiplied every side on this triangle by 2, then I would get 10, 24, and 26. Let's double check if that actually fits Pythagoras' theorem. So if this triangle is indeed a right angle triangle, then we should expect that 10 squared plus 24 squared should equal 26 squared. So let's have a double check. Now 10 squared is going to be 100. So that's 100. 24 squared, if you just chuck into your calculator, would be 576. And 26 squared is going to be 676. So you can see that 100 plus 576 does indeed fit in with this being a right angle triangle and fitting in with Pythagoras' theorem. So what's the use of that? Well, if I was to give you another triangle, let's say I gave you a triangle that had a hypotenuse of 15 and another side of, let's say, 12, what would the other side be in this triangle? Well, pause the video now and have a look at these 4 triangles. Which one of these triads do you think the triangle I've constructed looks like? Okay, so hopefully you've had a look at these 4 triangles and you can see that the triangle I've drawn looks most like this triangle over here, the 3, 4, 5 triad. Why is that? Well, you can see for 5 to become 15, I've had to multiply by 3. And that's the exact same with this side over here. The 4 has been multiplied by 3 to get 12. So what does that mean my x is going to equal? Well, my x would have to correspond to this side over here, the 3. Now, the ratio between these 2 triangles is 3 because 5 times 3 is 15, 4 times 3 is 12, which means x should just equal 3 times 3, which would be 9. So you can see I've been able to use these triangles and these triads to solve harder right angle questions without using a calculator. So to finish off this video, I want to draw your attention to this basic example here. Pause the video and have a go before I go through the solution. There are quite a few things going on in this particular diagram. What I want you to make sure you understand is that this side is equal to 16. Now, we're really interested in this right angle triangle over here. Why is that the case? Well, obviously, x is going to be a hypotenuse here, so we can use some sort of Pythagoras' theorem to figure out x. But first, we need to figure out what this side is here and what this side is here. Now, since this is 90 degrees, then that means this is also going to be 90 degrees because this is a straight line. Now, using Pythagoras's one of the triads, we can actually figure out what this side is equal to. So what I'll do is I'll just draw out this triangle in red so that we can see what we're looking at. So I'll draw it out again here. Now we know that this side is 16 and we know this side is 20. Now, what Pythagorean triad actually corresponds to this triangle? Well, we know this actually corresponds to 3, 4, 5. You can see that if I just draw that out again, this particular triangle would look like 5 being the hypotenuse, 4 being this side, and 3 being this side. You can see that to get from 5 to 20, I've had to multiply by 4. And to get from 4 to 16, I've also had to multiply by 4. So it means that this side over here, I'll call it x. Actually, I won't call it x because we've already used that. I'll call it y. That means that this side y is going to be 3 times 4. And so we can say that y is equal to 12. So that means I'm just going to make this diagram a bit more simple now. I'm going to say that this side here is going to be 12. Now we need to figure out what this side is over here. How do we go about doing that? Well, for this, we need to use one of the properties of a parallelogram. You can see that this shape is a parallelogram because opposite sides are parallel to each other. And the cool thing about a parallelogram is that the opposite sides are equal in length. So if this whole side is 21, then this entire side should also be 21. And since we've already been given that this is 16, well, it means that this is going to be 21 minus 16, which is 5. So now we can draw out a triangle where x is going to be our hypotenuse. I'll just trace it out here and I'll redraw it over here. So what we have is we have a right angle triangle. We have x as a hypotenuse because it's opposite the right angle. We know that this is 12 and we know this is 5. Now this is actually directly one of the triads we talked about. Can you remember which one? It's going to be the 5, 12, 13 triad. Now we already have the 5 and we already have the 12. And since the hypotenuse is the longest side, the hypotenuse is going to be 13. So from this particular question, we've worked out that x is equal to 13. So that's the end of this video on Pythagorean triads. Hopefully you've been able to memorize a few here and there so that you don't have to become super reliant on your calculator. We'll see you in the next video, which will be talking about some of the homework questions. Yeah, we'll catch you there.